Right, we are going to start with question number 1. It reads, prove that sine 3 theta is equals to 3 sine theta minus 4 sine cubic theta. Right, you can make use of trig ratios, identities, or you can make use of De Moivre's theorem. Right, I'm going to use trig identities. Right, so we have sine 3 theta, right? You can write it as sine 2 theta plus theta. Then you make use of the compound angle formula for sine. Right, so the compound angle formula for sine is sine open bracket A plus B is equals to sine A cos B plus cos A sine B, something like this, right? So 2 theta is going to represent A, theta is going to represent B. So if I'm to expand this, I'm going to get sine 2 theta cos theta plus cos 2 theta sine theta. I hope you are listening, right? But I want you to notice that sine 2 theta is identical to 2 sine theta cos theta, right? And I want you also to notice that cos 2 theta is identical to 1 minus 2 sine squared theta. So we are going to replace this cos 2 theta by 1 minus 2 sine squared theta. And sine 2 theta is going to be replaced by 2 sine theta cos theta. I hope you are listening, right? So 2 sine theta cos theta dot product cos theta plus, let me start by writing this sine theta open bracket 1 minus 2 sine squared theta, right? So you can notice that cos theta and cos theta, they multiply each other, giving you cos squared theta. So we now have 2 sine theta cos squared theta plus, then let us remove this bracket. Sine theta times 1, you get sine theta, right? Minus 2 sine cubic of theta if you multiply sine theta with sine squared theta, right? But since our identity on the right side is in terms of sine, it means we need to change this cos squared theta into sine. Making use of the identity sine squared theta plus cos squared theta is identical to 1. So if we make cos squared theta the subject, you can notice that cos squared theta is now identical to 1 minus sine squared theta. So I'm going to replace this with 1 minus sine squared theta. So you get 2 sine theta open bracket 1 minus sine squared theta plus sine theta minus 2 sine cubic of theta. I hope you are following, class, right? So let us remove the bracket. 2 sine theta times 1, you get 2 sine theta minus 2 sine theta times sine squared theta, you get 2 sine cubic of theta plus sine theta, right, minus 2 sine cubic of theta. I hope you are following. So 2 sine theta is the like term with the sine theta, and they produce 3 sine theta. Then minus 2 sine cubic theta minus 2 sine cubic theta, you get minus 4 sine cubic theta. Shown and proved. I hope you are following, class. Right. We are now moving on to part B of the question. It reads, hence or otherwise evaluate integral of sine cubed theta d theta with the pi over 3 upper limit and 0 lower limit. Right. This word hence, it means use the previous result to solve the current question. So in our previous result, we managed to prove that sine 3 theta is identical to 3 sine theta minus 4 sine cubed of theta. Right. So we can make sine cubed of theta the subject of the formula. I hope you are following. So this can be achieved by moving 4 sine cubed theta to the left side. Then you leave 3 sine theta to be followed by sine 3 theta, which become negative sine 3 theta. Divide both sides by 4, each and every term. So we divide here by 4, here by 4, and here by 4. 4 and 4, they cancel out each other, giving us sine cubed theta is identical to 3/4 sine theta minus 1/4 sine 3 theta. I hope you are following class. Right. So I'm now using this inside the integral. We now have 3/4 sine theta minus 1/4 sine 3 theta with pi over 3 upper limit and 0 lower limit d theta. I hope you are following class. Right. So remember, the integral of sine is minus cos. Right. So if we are to integrate 3/4 sine theta, you get minus 3/4 cos theta. I hope you are following, because the integral of sine theta is minus cos theta. I hope you are following. Right. Then we move on to this side. We want to integrate sine 3 theta. So the integral of sine 3 theta is minus cos 3 theta divided by 3, which is the derivative of 3 theta. I hope you are following. Right. So negative and negative, they produce a positive result, giving us minus 3/4 cos theta plus 1/12 cos 3 theta, where 12 is 4/3. Minus times minus, you get plus. Remember, we have pi over 3 as the upper limit, 0 as the lower limit. So let us maintain that. Right. So to then evaluate, it's now a matter of substituting the upper limit in the first bracket minus the substitution of the lower limit in the second bracket. I hope you are following. So we now have minus 3/4 cos pi over 3 plus 1/12 cos. Since we have 3 theta, it means 3 is going to multiply pi over 3. So if 3 multiplies pi over 3, you'll be left out with pi, since the 3's, they cancel out each other. Right. Then in the second bracket, we substitute the lower limit with this 0, minus 3/4 cos 0 plus 1/12 cos 0. I hope you are following class. Then make sure that your calculator is in radians before you punch. Right. So I'm going to start by identifying cos pi divided by 3. Cos pi divided by 3, you get 0.5, which is good as half. Right. So in this, we have minus 3/4, open bracket, half, representing cos pi over 3. Then cos pi, you get minus 1. Right. So plus 1/12, open bracket, minus 1. Then cos 0 is always 1. So you now have minus 3/4, open bracket, 1 plus 1/12, open bracket, 1. I hope you are following class. Right. So 3 times 1 you get 3. 4 times 2, you get 8. So this is minus 3 over 8. Minus 1 over 12. Then minus and minus, you get a plus 3 over 4. Minus and plus, you get minus 1 over 12. I hope you are following class. So let us punch everything in our calculator. Over 24. So our final answer is 5 over 24. Then you are home and dry. I hope you are following class. Right. So I want you to stay tuned as we move on to question number 2. Find the 2 possible values of k for which the line 4y plus 3x is equals to k is a tangent to the curve x squared plus y squared minus 4x minus 21 is equals to 0. Right. So it is very simple. Let me dramatize by drawing the circle as well as the tangent. So the tangent here is 4y plus 3x is equals to k, right? Then we are given the circle as x squared plus y squared minus 4x minus 21 is equals to 0, something like this, right? Remember, to find the center, right, of the circle, you divide the coefficient of x and the coefficient of y with minus 2. So in simple terms, x squared plus y squared minus 4x, since we do not have a term in y, it means we have 0y minus 21 is equals to 0. Divide the coefficient of x by minus 2 and the coefficient of y by minus 2. So minus 2 into minus 4, you get the x coordinate of the center, which is 2. Then minus 2 into 0, you get 0. So the center is 2 and 0. I hope you are listening, class, right? Then the next thing to do is identify the radius of the circle. So the radius of the circle is r is equals to square root f squared plus g squared minus c. I hope you are following. So r is equals to f squared, you can even use 2 squared plus 0 squared minus c represent the independent term, the one without x or y, and this independent term is minus 21. So I'm going to put minus 21 on c, something like this. I hope you are following, class. So r is equals to square root 2 squared, you get 4, 0 squared is 0, minus and minus, you get plus. So 4 plus 21, r is equals to square root of 25, which gives you 5 units. So our radius is 5, right? So to then find the possible values of k, you need to calculate the distance of the center to the tangent and equate it to 5, which is the radius itself. I hope you are following. So what you need to do is move everything to the left side on the equation of the tangent. You get 4y plus 3x minus k is equals to 0. Then distance is equals to modulus 4y plus 3x minus k represent your numerator. Then put square root. Coefficient of y is 4 squared, right? Plus coefficient of x is 3. Then you raise 3 with the power 2, something like this. I hope you are following. Equate it to 5. Right. So what you need to do now is, since the coordinates of the center are 2 and 0, 2 is representing the x coordinate and y is, 0 is representing the y coordinate. So you put 0 on y and you put 2 on x. I hope you are following. So 4 open bracket, put 0 on y, plus 3 open bracket, put 2 on x minus k all over 2. 4 squared plus 3 squared. So 4 squared plus 3 squared, you get 25. You put 25 here, it's equals to 5. I hope you are following, class. So 4 times 0 is 0. 3 times 2, you get 6 minus k over square root of 25 is 5. Then equate it to 5. So since we have modulus, it means raise both sides with power what? With power 2. I hope you are following. Right. So after raising both sides with power 2, I'm going to move 5 squared to my left side. So you now have 6 minus k over 5, right? Squared minus 5 squared, then it goes to 0. Make use of extraction of roots, right? You get 6 minus k over 5 squared is equals to 25. Put square root both sides. 6 minus k over 5, right, is equals to plus or minus 5. I hope you are following. So the first possible value of k is going to be obtained by equating 6 minus k over 5 with positive 5. Then the second possible value of k is going to be obtained by equating 6 minus k over 5 with minus 5. I hope you are following. So if we cross multiply here, 6 minus k is equals to 25, or 6 minus k is equals to minus 25, right? So we can move k to the right side and 25 to the left. You get 6 minus 25, which is minus 19, is equals to k, right? Then if you move k to the right again and move 25 minus 25 to the left, you get plus 25, giving you 31 is equals to k. So the possible values of k are 31 and minus 19. Then you are home and dry. You get yourself the 7 marks. We are now on question number 3. It reads, express g of x is equals to 2x minus 1 over x minus 3 in the form g of x is equals to a plus b over x minus 3. Right, you can make use of long division or the algebraic juggling technique, whichever way you are comfortable with. Right, so long division is the most common method, right? So x minus 3 is going to divide 2x minus 1. I hope you are following. Right. So the first term is x. X, the first term into 2x, you get 2. I hope you are following. Then multiply 2 times x, you get 2x. Then 2 times minus 3, you get minus 6. So 2x minus 2x is 0. Then minus and minus, you get plus 6. 6 minus 1, you get 5. I hope you are following. So it means your result is 2 plus 5, the remainder, divided by x minus 3. I hope you are following. Right. You get yourself 2 marks for that. This is our part A. We move on to part B. Hence, state the correct sequence of the transformation, right, which transform the graph of y is equals to 1 over x onto the graph of y is equals to g of x, right? So the correct sequence, they need you to provide your answer using the correct sequence. So the first one, which is the first transformation, is going to be obtained here on x minus 3. Right, you can notice that x minus 3 represent a translation in the x-axis, or a translation along the x-axis. So you write translation, right, along the x-axis. Then you give the vector. Right, since we have a negative here, you write the positive 3. Right, so the vector is 3 and 0. Then we move on to the second sequence. Right, the second sequence is going to be obtained on 5. Right, 5 is multiplying 1 over x minus 3. This 5, which is multiplying 1 over x minus 3, represents a stretch along y-axis. So you write stretch along y-axis. Then do not forget to give the stretch factor. So the stretch factor is 5. Right, I hope you are following. Then we move on to the third one. And the third one is going to be obtained by 2. These 2 represent translation along y-axis. So you write translation along y-axis. For translation, you describe it using a vector. So the vector is 0 and 2. I hope you are following. Right. So to be specific, you can say translation along the positive x-axis direction. Stretch along the positive y-axis direction. Translation along the positive y-axis direction. Then your vector is 0 and 2. So this is how you are supposed to do. Let us move on to the next question. Right, we move on to part C of the question. It reads, sketch the graph of y is equals to g of x, showing clearly any asymptotes and intercepts with the x-axis. Right, so let me start by identifying the asymptotes. Remember, we got y is equals to 2 plus 5 over x minus 3 after carrying out the long division. Right, so an asymptote is a line which must not be cut by the graph or by the curve, as it contains the values of x and the values of y, which makes the whole function invalid. The first asymptote is going to be taken from the denominator x minus 3, right? The fact that 0 cannot be denominator whatsoever. So it means x minus 3 is not allowed to be equivalent to 0. I hope you are following. So we need to find the value of x which makes the denominator 0. Move minus 3 to the right side, a positive 3, right? So we are saying that x cannot be equivalent to 3. Because if we put 3 on x, you get 0 as the denominator, of which 0 cannot be a denominator. I hope you are following. So I'm going to draw my first asymptote, which is 3. Here is my sketch. The y-axis as well as the x-axis. Draw a vertical line passing through 3 on the x-axis. Right. Let me use dotted lines here. So this vertical line is going to represent our first asymptote. Label it x is equals to 3. I hope you are following. Then the second asymptote is y is equals to 2. Why y is equals to 2 is an asymptote? Because if you put 2 on y, right? Let's say you put 2 on y. You get 2 is equals to 2 plus 5 over x minus 3, something like this. I hope you are following. But 2 minus 2, you get 0. Is equals to 5 over x minus 3. And if you are to cross multiply, you will realize that x minus 3 and 0, they produce 0, of which 0 cannot be equal to 5, which is 1 times 1. So we cannot have real values of x when y is equals to 2. That's why y is equals to 2. This value is also an asymptote. I hope you are following. Right. So I'm going to draw another asymptote here. Passing through the value of y, which is 2, then label it y is equals to 2. I hope you are following. Right. You can also make use of the limit theory that if 5 over x minus 3 becomes too large, right, as x approaches infinity, this entire fraction, it tends to approach 0. Since the denominator becomes too large, whilst the numerator remains constant, right? So it tends to give y is equals to 2, but y is equals to 2 must not be cut by the graph. I hope you are listening. Right. The value of x when y is 0 and the value of y when x is 0. So when x is 0, you get, if you put 0 on this, you get minus 1. Put 0 on x, you get minus 3. So when x is 0, y is 1/3. So the first point is 0 and 1 over 3. I hope you are listening. Right. So where is 0 and 1 over 3? A third is here. You label it 1 over 3. I hope you are following. Then we now need to find the value of x when y is 0. So if we put 0 on y, you get 0 is equals to 2x minus 1 divided by x minus 3. Cross multiply, you get 2x minus 1 is equals to 0, which is 2x is equals to 1 and x is equals to half. So x is equals to half when y is 0. You have half and 0. So half is between 0 and 1, something like this. I hope you are following. So as you draw your curve, you approach the asymptote, but you don't touch, passing through the intercepts. Remember, these are our intercepts, right? Something like this. So you just approach, but you don't touch the asymptotes. I hope you are following. Approach, but you don't touch. Right. Then on the opposite quadrant, you draw another curve approaching the asymptote, but don't touch. Something like this. So this is how you sketch the graph y is equals to 2x minus 1 over x minus 3. I hope you are following, class. Let us move on to question number 4. The diagram shows a container in the form of a right circular cone of height h and radius r. The height of the cone is 10 centimeters and diameter is 2 centimeters. I have underlined the critical statements that are going to assist us in solving this question. And this is one of the critical statements. The height of the cone is 10 centimeters when the diameter is 2 centimeters. Right. The container catches water, right, from a tap leaking at a constant rate of 0,1. The height and radius are always proportional. Find the rate at which the top surface area of water is increasing when the water is halfway up the cone. 9 marks. Right. So our starting point is height and radius are always proportional. Right. So I'm going to link this statement with this first statement, 10 centimeters for height when diameter is 2 centimeters. I hope you are listening. So let us apply the variation concept. If height and radius are always proportional, it means h is proportional to r. Then you put equal sign, then you multiply the right side with the constant of proportionality, which is k. Right. So height is equals to 10 centimeters when diameter is equals to 2 centimeters. So if diameter is equals to 2 centimeters, it simply means that radius is equals to 1 centimeter, since radius is half diameter. So I'm going to put 10 on h. I hope you are following. Then I'm going to put 1 on r. So 1 times k, you get k. It means k is equals to 10. I hope you are following. Right. So if K is 10, H is equals to 10R. So this result is very, very important in our journey. Right. So after that, I advise you to put a demarcation line. We have two things under consideration here. The first is the volume. Then the next thing to consider is the area. Right. So differential coefficients of volume, I'm going to place them on my left side, and the differential coefficients of area, I'm going to place them on my right side. So the first differential coefficient of volume is going to be generated by the words catches water. Right. So the cone is catching water from a tap leaking at a constant rate of 0.1. I want you to understand something here. The cone is not the one which is leaking, right? But there is a tap which is leaking, and the water which is leaking from the tap is entering into the cone. Hence, the cone is receiving, right? So, catches water, it means the rate of increase of water in the cone with respect to time. And the differential coefficient for catches water is dV dt, and it is a positive differential coefficient. Why? Because the volume in the cone is increasing, right, by receiving the water which is leaking from the tap. I hope you are getting me, class, right? So the rate at which the tap is leaking is good as the rate at which the water is entering in the cone. So if the tap is leaking at 0.1, it means the cone is also receiving at 0.1. Take note of that, right? Then another differential coefficient is going to be generated from the question itself. Find the rate at which the top surface area of water is increasing. So we refer to this as dA over dt, the rate at which the top surface area of water is increasing. So this one is unknown. This is our target. If we are to find this, you get yourself 9 marks. Right. When the water is halfway up the cone, right? It is very important when water, right, is halfway up the cone. Take note of this crucial statement, right? So, what I want you to do now is we need to create another differential coefficient on the volume side. This is achieved by writing the formula for the volume of the cone, which is 1/3 pi r squared times height. After that, you need to remove this h and replace this h with the 10r. Remember, h is equal to 10r from the proportion, right? So I'm going to put 1/3 pi r squared, then you put 10r on h, something like this. So if you multiply, you get 10 over 3 pi r cubed, which is your volume, right? So the next differential coefficient is dV dr, which is going to be generated by differentiating the right side. So 3 is going to multiply 10 over 3 pi. Then you less 3 with 1, you'll be left with the 2. You can clearly notice that 3 and 3, they cancel out each other, giving you dV dr is equal to 10 pi r squared, which is the differential coefficient generated from the volume side. I hope you are listening, class. We also need to generate another differential coefficient from the area side by understanding that find the rate at which the top surface area of water. So the top surface area of water is in the form of a circle. I hope you are listening. So area is going to be represented by pi r squared, which is the area of a circle, as a circle is being formed on the top surface of the cone. I hope you are listening, class. So I'm going to find dA dr. So 2 times pi, you get 2 pi. Then replace 2 with 1, you get 2 pi r. I hope you are listening. Right. Remember, our target is to find dA dt. Right. So to find dA dt, you make use of chain rule. Right. For the chain rule, you are going to say dA dt is equals to dA over dr times dr over dv times dv over dt. Why? Because you can clearly notice that dr and dr, they cancel off each other. dv and dv, they cancel off each other, and you'll be left with the dA and dt, giving you the requirement, which is the rate of increase of area of the top surface with respect to time. I hope you are listening. Right. So we want to substitute the differential coefficient that we have obtained in this chain rule. The first differential coefficient is dA dr. So dA dr is 2 pi r. I'm going to put 2 pi r on dA dr, then you multiply. Right. The next is dr dv. So dr dv is going to be obtained by reciprocating dv dr. So if dv dr was 10 pi r squared, it means dr dv is 1 over 10 pi r squared. I hope you are listening. Then we now need dv dt. So dv dt was generated from the words catches water, as the cone is receiving water from the tap, which is leaking at a constant rate of 0.1. It means the cone was increasing in volume with the 0.1. So dv dt is going to be taken as it is, 0.1, but 0.1 can be written as 1 over 10. I hope you are listening. Right. So you can clearly notice that pi is a factor of pi. So pi and pi, they cancel off each other. 2 is a factor of 10. So 2 into 10, you get 5. R is a factor of r squared. R into r squared, you get r. I hope you are listening. So 1 times 1, you get 1. 5 times 10, it's 50. But remember, we still have this r. So the rate of increase of the top surface area with respect to time is 1 over 50 r. Right. But remember, there was a statement when the water is halfway up the cone. Right. So you need to be very careful. The examiner is not requiring you to find the rate of increase of the top surface area with respect to time when the volume or when the tank is half full. When the tank is half full is different from this words water is halfway up the cone. So if water is halfway up the cone, they are referring to, remember, the height of the cone is 10 centimeters from the bottom to the top. So the water is going to be halfway up the cone when the height of the cone is 5 centimeters. I hope you are listening. Right. But if the question says, find the rate at which the top surface area is increasing when the cone is half full. For such a question, you start by calculating the total volume when the cone is full. You write a third of pi r squared h, something like this. Then you say V is equals to 1 over 3 pi. Remember, 1 is the radius, right? Then h is the height. So if you use height of 10 and radius of 1, you get the total volume when the cone is full. And the total volume when the cone is full is going to become 10 over 3 pi. That's the total volume when the tank is full. Then you multiply this by half. So if you multiply this by half, it means if the cone is half full, you get 5 over 3 pi cubic centimeters in terms of volume, right? Then to find radius, you then need to go back to the left side where we replaced h with the 10r. We got v is equals to 10 over 3 pi r cubed. So you say 5 over 3 pi is equals to 10 over 3 pi r cubed. You can clearly notice that pi and pi, they cancel off each other. 3 and 3, they cancel off each other. If you divide both sides by 10, you get half is equals to r cubed. It means cube root of half is equals to r. So this is the radius that you use if the question states that find when the cone is half full. You replace this r right in front of this 50 with cube root of half to find your final answer, right? But the question here is asking otherwise, right? Find the rate at which the top surface area of water is increasing when the water is halfway up the cone. Up the cone, it means that we are concerned about the height only, not about the capacity, right? So up the cone, from the bottom of the cone to the maximum point of the cone, we have 10 centimeters. So halfway, it means 5 centimeters. So I would like to find when the height is 5. I hope you are listening. So when the height is 5, you go back to this proportion, put 5 on h, you get 5 is equals to 10r, divide both sides by 10, you get 1 over 2 is equals to r. So I would like to find when r is half. So I'm going to put half on r, you get 1 over 50, open bracket 1 over 2. So 50 times half is 25, and this is your final answer. 1 over 25 is the rate at which the top surface area of water is increasing with respect to time when the water is halfway up the cone. And halfway up the cone is when the radius is half. I hope you are listening. Right. I hope you are listening. Right. But be careful, because some of the questions, they say find the rate at which the top surface area of the water is increasing when the cone is half full. For such a question, you substitute r with the cube root of half, whereby you start by calculating the 100% capacity, then you multiply it by half, then you equate it to 10 pi r cubed to find r when half full. But here we are concerned about the height. I hope you are listening, class. So I want you to stay tuned as we move on to the next question. Right, we are now on question number 5. It reads, by sketching a pair of 2 possible graphs, determine the number of real roots. Right, e to the power of minus x is equals to 2x squared minus 1. So let us draw our y-axis as well as our x-axis, something like this. I hope you are following. So I'm going to start with y is equals to e to the power of minus x. We want to find the value of y when x is 0 and the value of x when y is 0. So if x is 0, you get y is equals to e to the power of 0, which is 1. So you have 1 here. So 0 and 1, this is 1. This is our first point. Then, if we put 0 on y, you get 0 is equals to e to the power of minus x. But remember, to solve this, you try to put ln both sides. But I want you to understand something. There is no ln of 0. It means y is equals to 0 is an asymptote line. So what is y is equals to 0? Y is equals to 0 is good as the x-axis itself. So the x-axis is good as y is equals to 0. So our curve is not allowed to touch this y is equals to 0. I hope you are following, class. Right. Then, after that, you need to understand that we have a negative x. A negative x denotes that our curve is going to move in a leftward direction, right? And the values of x are going to, the values of y are going to decrease as x approaches infinity, because e to the power of minus x can be written as y over e to the power of x. So, as x becomes too large, you can clearly notice that our denominator becomes too large and the entire fraction tends to approach 0. So as the values of x are increasing, this function tends to approach 0. So we are going to draw our curve using this shape, showing that as the values of x are increasing, this tends to approach 0. I hope you are following. And this negative x indicates that we have a leftward shift, something like this. I hope you are following, class. Right. Then we need to sketch the quadratic graph. Y is equals to 2 x squared minus 1 is the value, right, of y when x is 0. And what is the value of x when y is 0, right? So the value of y when x is 0, we are going to put 0 on 2x squared, you get minus 1. So 0 and minus 1. This is our first point here. I hope you are following. Then we want to find the value of y when x, the value of x when y is 0. So put 0 on y, you get 0 is equals to 2x squared minus 1. Minus 1 to 0, you get 1 is equals to 2x squared. Divide both sides by 2, half is equals to x squared. Extraction of roots, plus or minus. Square root of 1 is 1 over root 2 is equals to x. So you have minus 1 over root 2 or 1 over root 2 is equals to x. I hope you are following. So I'm going to put 1 divided by root 2 here. Then I'm going to put minus 1 divided by root 2 on my left side. So if you are to draw the curve, it passes through minus 1 over root 2 and also here, heading towards 1 over root 2, something like this. Then you label y is equals to 2x squared minus 1. I hope you are listening. Right. Since the two curves intersect twice, it means that the equation has two real roots. So this is the conclusion that you give. Since the two graphs intersect twice, it means that the equation has two real roots. Right, we are now moving on to part C of the question. It reads, use the iterative formula xn plus 1 is equals to square root of 1 plus e to the power of minus xn all over to 2. Taking x1 is equals to 1 to find the root of e to the power of minus x is equals to 2x squared minus 1, giving your answer to 3 decimal places. Right, so it is very simple. Right, the first initial value is x1 is equals to 1. So you need to find x2, x3 up to the stage where you start to see the recurrence of the same numbers. I hope you are listening. So to find x2, you need to put 1 on xn. So you get 1 plus e to the power of minus 1 over 2. If you punch this in your calculator, it produces 0.827 is x2. Right. So let me teach you. Let's say this is your calculator. I hope you are listening. You put square root, then you put open bracket, something like this. You can put another open bracket, then punch 1 plus second function exponential plus or minus 1, close bracket. Divide this by 2, close bracket, equals, you get 0,827 to 3 decimal places is required. Right, then to find x3, you can use this button, the backspace button, then remove minus 1 and put 0 minus 0,827. The result in x2 is now substituting minus 1. So 0, right, comma, 827. Then you just say equals. It means you get 0,848 to 3 decimal places. Then to find x4, you just do the same. Use this backspace button, right? Erase 2 and 7 and replace 2 and 7 with 4 and 8. So 4 and 8, then equals, you get 0,845, right? Then we move on to x5. To find x5, right, you need to remove 8 and replace it with 5 so that you have minus 0,845, which is the x4 value. Then equals, you get 0,845. So on this one, you have to stop since you have seen the recurring of 3 decimal places which are identical. So your final answer is 0,845. Then you are home and dry. Right, so we are now through with section A. Right, so I want you to subscribe to my channel so that you don't miss new videos when posted. We are going to continue with this paper as we work on the section B of the paper. Do not miss. My name is MAPANDA. Thank you for watching. Invite as many people as possible so that they can also benefit to our YouTube channel. Be blessed.